In this video, I would like to talk about polymorphism. So right here, I have a Stack Overflow thread about what polymorphism is. So just to get the actual definition of polymorphism. So poly means many and morph means form. So many forms. So basically, polymorphism is the ability to present the same interface for differing underlying forms. For example, in many languages, integers and floats are implicitly polymorphic, since you can add, subtract, multiply, and so on. To get a better understanding of how polymorphism can be used, let's look at some code. One thing that people talk about when they say polymorphism, they simply refer to what is called compile time polymorphism, or it could also be runtime polymorphism. So what is runtime polymorphism? So runtime polymorphism can be achieved with what's called method overriding. An example that people usually mention when they talk about object-oriented programming is the animal concept, because it's the easiest way to, or it's an easy way to describe hierarchies. Let me just write an animal class. This will have one method, which I would say make sound. What it should do is basically just say make sound. And if I now instantiate an animal and I say a.make sound, then we see that I get the makes sound. That's good. But what if I want to create a child? So another class which will also be an animal. So let's say I'll make a cat class, and I will say this will inherit from animal, right? Like that. So it extends animal. It should say meow. So what I'm doing here is I'm overriding. So this is called overriding, method overriding in object-oriented programming. And it's also referred to as runtime polymorphism, because as we can see here, I can make a cat, and I will say cat.make sound, and we see meow. Basically what it does is that we can take another type and call the same method on it. And this can be useful for maybe achieving different behaviors in runtime. So you might want to have different sub behaviors, and you have one super behavior, and you want to call, or you want to run the different behaviors without having to check what type it is. So that's a way to add flexibility in code. Compile time polymorphism is about method overloading. So that's a different type of polymorphism. It's not something that you change in runtime. So as I said, polymorphism in runtime would be you can exchange an instance in runtime and still call the same methods, because you know that there will be an overriding already. So you can in runtime change things of different forms. But in compile time, you basically talk about it and you refer to method overloading. So method overloading allows us to have many methods in the same name, but different actions in the same class. So this can also give a bunch of benefits to a developer. So let's look at an example. So I will create a calculator class, and it will have a sum method, and it will take a number and another number. And if we, what it should do is basically it should just return the sum of these two numbers. But we might also want to have another signature. So this signature, let me just try to run this. This should give us, result should be 3. So that's what we see now. So the result is 3. But what if we also wanted to say, and we might want to have a third argument? Would that be possible? So currently it wouldn't. So result 2, it won't work. So we see that it expects 2 arguments, got 3. But sometimes you want to be able to have one method, but pass different things to this method. So it could be either different parameters, or I mean the number of parameters might change, or the actual data types might also be different. How do we achieve this in TypeScript? So as I said, this won't work because there is nothing that supports this type of signature at the moment. What we can do is I can say something like this instead. So this would be method overloading in TypeScript. So now I'm defining a bunch of signatures. So either the sum can be 2, it can have 2 arguments, both are numbers, or it could have 3. And then the actual implementation or the definition of the function, I have to say that this is an optional parameter because that's how, otherwise it wouldn't be compatible, the different signatures. And the reason for this is that TypeScript doesn't really support method overloading in the sense that you can write different types of function definitions and use them as method overloading, but you have to write one implementation, but you have to implement it in such a way that it covers all the needs in the different signatures. Basically, you evaluate the different parameters. So here, since this is optional, I have to check if this is defined. If it's not, then I simply just return a plus b. Otherwise, I sum all the values if they are defined. So now this should work. So now we see we don't get an error. So if I say result 2, we get 6. So that's good. And also, if I want to say result 3, and I just say sum, we can see that even in the editor, it says that there are actually 2 or 3 arguments. You can see that I have both signatures available. So I can say 5, 5, but I can also say 10. So both would be relevant and be valid. So I can say, yeah, as we see here, so 5, 5 will give me 10, 5, 5, 5 will give me 15. So this is completely valid code. So this would be what you call compile time polymorphism. And there are many other use cases for polymorphism. One of them is that you can achieve what's called the open-close principle. And that's another video where I would dive into what how open-close principle is about. So that's a little bit about polymorphism. I hope this example made sense. Please leave your comments below and let me know what you think about polymorphism, and do you have any other examples? Usually I don't like the animal example because I think it doesn't relate to software very much. It's not very common that you would write software about animals. You could say that maybe if you build a game, then it would make sense. But I mean, in most cases, a more realistic example would be optimal. But yeah, in lack of better examples, this is what I had to share for this time. Thanks for watching and see you in the next one.